In last lecture, I discussed about critical section problem, how the critical section problem is solved using some algorithm. In this section, I will discuss the hardware solutions and semaphore technique. Synchronizations using हार्डवेयर. अभी तक हम लोग सॉफ्टवेयर सॉल्यूशंस के बारे में बात कर रहे थे. लास्ट जो एल्गोरिथम था दैट इज सॉफ्टवेयर सॉल्यूशंस टू द क्रिटिकल सेक्शन प्रॉब्लम. नाउ आई विल डिस्कस द सिंक्रोनाइजेशन हार्डवेयर. दैट इज इट इज अ हार्डवेयर टेक्निक्स फॉर द सॉल्यूशन ऑफ क्रिटिकल सेक्शंस प्रॉब्लम. ये हार्डवेयर में इस तरह का इंस्ट्रक्शंस अवेलेबल होना चाहिए तभी ये इम्प्लीमेंट हो सकता है. दिस इज ए वेरी सिंपल इंस्ट्रक्शंस, टेस्ट एंड सेट इंस्ट्रक्शन. इट इज ए फंक्शन. इट कंसिस्ट ऑफ ए आर्गुमेंट, one argument, having boolean type, and it also returns a value of boolean type. That is, if test and set instruction execute, it returns a boolean value, either true or false. The code is follows: begin test and set is equal to target. If the target value is initialized with a false value, then the functions will also return a false value. Similarly, if the target is assigned a true value, it returns a true value. In this way, the test and set is equal to target. That means if the function is executed, then if the target is equal to false, then test and set is also false. If target is true, then test and set is also true. After that, the target is made true. Now, how this is implemented to solve the critical sections problem? How test and set is implemented to handle the critical section problem? There is a global variable, waiting and lock. Waiting is an array type variable, lock is a boolean type variable. Pi is a process, that I stands from 0 to n minus 1. Key is a boolean variable. Waiting I, that is waiting 0. If 0th process want to enter the critical sections, then waiting 0 is equal to true. It is a local initialization. Similarly, key value is also initialized with a true value. Key is a local variable. Now, how the code while waiting I and key do key, test and set lock. This code is executed to enter into the critical section. This is the code for entering the process into the critical sections. Now, key, here is a key, test and set lock. Lock is the argument of the test and set. If lock is true, then it returns a true value, and if lock is false, then it returns a false value. Now, initially, all the values in lock and array make initialized with a false value. So the lock, after executing the test and set lock, it returns a false value, that is key become false. So waiting I is true but key is false, so this code will not execute it. That is, it become false. When it become false, it enter into the critical section. This is critical section. After executing the critical sections code, it make in the exit sections, it make j is equal to I plus 1 mod, and that it initialize. It increment the I by 1 so that the next process can enter into the critical section. It is a modular arithmetic system, since the array is fixed of size n. So after 10, if there is 10 processes, then again 10 it go back to its 0th positions. Then it is a mod 10 arithmetic. If there is 11 locations, it is mod 9 arithmetic. If it has 10 locations, etc. Now in the exit sections, how this code is executed to implement the progress principle. Actually, in the entry sections, we have seen that at a time, this is the entry sections of the code. At a time, only one process can execute the critical sections code. But at the exit sections, it has to hand over the critical sections to any one of the process. So the code executing in this manner: if j is not equal to I and not waiting j, then do j is equal to j plus 1 mod n. इसका मतलब ये है कि अगर not waiting j is true, that means waiting j is false. If waiting j false, that इसका मतलब है कि j को नहीं चाहिए. अगर मान लीजिए कि j के पास हम भेज दिए और j को नहीं चाहिए, तो क्या होगा? j का वैल्यू 1 से इंक्रीज करते रहेगा. उसके बाद नेक्स्ट मान लीजिए कि 1 है, उसके बाद 2 आएगा, उसके बाद 3 आएगा. तो ये कोड कंटिन्यू होते रहेगा जब तक ये ट्रू रहेगा. जब तक ये स्टेटमेंट ट्रू रहेगा, तब तक ये कोड एग्जीक्यूट होते रहेगा. जब ये वेटिंग j इज इक्वल टू ट्रू हो जाएगा, दैट इज नॉट वेटिंग j इज इक्वल टू फॉल्स, देन ये स्टेटमेंट फॉल्स हो जाएगा. तो फॉल्स होने से ये जो कोड है ये एग्जीक्यूट नहीं करेगा. तो इसके बाद यहाँ पे आ जाएगा, नीचे आ जाएगा. Next, is a semaphore. Semaphore is another technique. Semaphore is a semaphore is a shared variable techniques to handle the concurrency critical section problem. It is an integer variable. How it works? It has two state, wait state and signal state. In wait state, while s is less than 0, do no operations. s का वैल्यू मान लीजिए कि ये 0 से कम है तो कोई ऑपरेशंस परफॉर्म नहीं करेगा, तो ये वेटिंग स्टेज में ही रहेगा. इफ s is equal to 0, then it enter into the critical sections. ये जो फर्स्ट वेट s, ये जो कोड है, ये कोड तब तक एग्जीक्यूट होगा जब तक इसका वैल्यू 0 से कम ना हो जाए और 0 से इक्वल ना हो जाए. और इस तरह से s इज इक्वल टू s माइनस 1, ये जो कोड है ये चालू होते रहेगा. सिग्नल s ये इंक्रीमेंट कर देगा s वेरिएबल को. ये दो सिंपल स्टेट है, दो सिंपल फंक्शन है, और ये दोनों ही एटॉमिक नेचर्स के हैं. एटॉमिक नेचर्स मतलब ये अगर हार्डवेयर में इम्प्लीमेंट करेंगे तो एक से ज्यादा इंस्ट्रक्शंस इसमें लग सकता है, लेकिन सभी इंस्ट्रक्शन एक ही साथ एग्जीक्यूट होना चाहिए. जैसे कि हम लोग लास्ट एग्जांपल में देखे थे, काउंटर इज इक्वल टू काउंटर प्लस 1 शुड बी एटॉमिक, but it contain 3 instructions, 3 assembly language instructions. So next we have to see how it is implemented to solve the critical section. This is the algorithm how semaphore variable can be implemented to handle the critical section problem. Now process PI, there is two variable. One is a semaphore. It is initialized with mutex equal to 1. Sorry, there is one variable, only one variable, mutex. It is initialized with 1. How the algorithm is executed? This is the algorithm. Now wait mutex. Now mutex, the value of mutex is the argument of the wait. Now mutex is initialized 1. Now this wait variable, this wait functions will be executed. Now the value is s is equal not if it is less than equal to 0, it is 1. Here it is 1, so there is no operations. It come to s is equal to s minus 1. Now s value of s is equal to 1, so become, that is mutex variable value become 0. Now other process which are executing these sections, it see that s is equal to 0. That means s is not s is less than equal to 0. So other process will not enter into the critical sections. Now the process which has entered into the critical section, it execute the critical sections code. Then it execute the exit sections, that is signal. In signal mutex, that is mutex value, that is means s is equal to s plus 1. That s has a 0 value, it is incremented by 1. Now s become 1 and it exit from the section. This is s is equal to s plus 1. This is executed by the signal and the s become 1. Initially it is 0, now it is, after executing signal, it become 1. Afterwards the remainder sections is executed. In this algorithm, the mutual exclusion principle is satisfied, and whenever a process executing the critical section, other process cannot enter into the critical sections. In this lecture I discuss how test and set instructions is implemented. Actually test and set instructions can be implemented if there is hardware facilities. If hardware not support the test and set instruction, the algorithm cannot be implemented. And second, principle of semaphores. Semaphore is a simple variable, shared variable technique to solve the critical section problem. Semaphore variable cannot perform the progress and boundedness of a critical section problem. In the next lecture, I will discuss start a new topic, deadlock, which is a natural phenomena occurring operating system. Thank you.